Can you please not use that?
All right. Okay. First, what we're talking about, we're going to be talking about factoring, breaking things up into items that multiply together. That's what a factor is. In fact, let's write that down. The idea of what a factor is, I think that definition is lost on people, like what you're actually doing. Because the word I always hear is, I want to foil, whatever. I'm going to do one of them to this problem. Factoring is you're finding items that multiply together. Multiply together to form the product. Okay, the product is the result of multiplying, right? That's the key word that most people have that misconception about. But you're trying to find the items that multiply together. It's like you have the answer and you're going backwards. So if I give you like the number 12, there's factors of 12, right? There's items that multiply to give you this number. This number is actually the product, the result of multiplying numbers together. So options you have are stuff like this, right? That's factor. You're breaking things up into numbers. That concept, the idea of breaking up numbers, is actually inside of the factoring process that you guys learned in Algebra 2 when you start doing parentheses and all that. The goal today was, because I just kind of gave you the words yesterday, the goal today was kind of intro the different forms and kind of walk through them so that you're comfortable with them. I know that you've seen this stuff a lot. Like one of the comments I had yesterday was like, trinomial is the one we did a lot in Algebra 2. That's great, I understand that. But some of the others maybe you didn't, or you didn't understand the rule when you did see it. Like you didn't know the process for doing it. So the goal is to kind of walk through these today, go through maybe a couple examples of each until a point where you feel comfortable, and then we'll kind of move on. The ones I'm really concerned about is cube rule, to make sure you understand the process for a cube, and grouping. And so we'll pull problems right out of the book today, so hopefully somebody has a book in here. I see at least a couple. We can pull some problems out of the book, and we'll kind of show you the steps for those, because I like to use actual problems for those, because these can be tough just trying to make them out, because you've got to have certain stipulations in them. Okay, questions on what we're going to be doing here today? I thought that was important. We have to talk about the definition, because if you don't know the definition, then there's no point in doing into this. We're trying to find items that multiply together. All right, in fact, I'm just going to leave that there. So next, let's talk about how to do common factors. So common factors. This is the go-to method of factoring right away at the beginning of your problem. Like when you start a problem, this should be the first one you attempt every single time, because it will make your problem significantly smaller. Like the numbers that are in your problem or the variables. It will make everything easier to look at. It's definitely something you just need to notice. You need to spot it. So one of the examples I think I had yesterday on the board, I don't know, something like this. X squared plus 8x to the third plus 12x to the, let's go 7. I'm just gonna make that. All right. So when you're going through this problem, it doesn't matter if it's adding or subtracting. There could be 19 different items across the board. It really doesn't matter. What you're looking at is for common factors, you're looking at each monomial, each item that's separated by a plus or minus sign, and do they have something in common? That's what a common factor is. Every single item has to share. So what I always look for first, numbers. 4, 8, and 12. What number do they have in common? 4. Yep, because what you're looking at is this again. You're breaking every number up into all these numbers that multiply to give you, 12, that multiply to give you 8, multiply to give you 4, and you have the whole list in front of you, or you got it in your head. You got to figure out the one number that they all have. Usually what I start with the smallest number that I can see out of the 3 and see if it goes into the other 2, which it does. So you're right, we're going to pull out a 4. Now, is there any variables that all 3 of them share? An x squared. At minimum, 2 x's. Minimum 2 x's. Because this one has 3, that one has 7, so they at least all have 2 of them. That is a common factor. So you're going to pull that item out of one parenthesis. You're gonna pull it out. And what you're left with should be, in the parentheses, the item that's in that parentheses should be the same size as the item that you started with. So what was the item we started with? Was it like a monomial, binomial, trinomial, polynomial? What type is it? It's try. The thing in the parentheses better still be a trinomial. That's a misconception. Most people think, oh, I took it out, it's gone. No, the item that's left has to be the same size as what you started with, because you have to distribute it back in. So what I do is just take 4x squared and divide by 4x squared. What do you get? 1. People forget that. You need a 1 there. You divided them and made 1. Because you're actually dividing it out. 8 divided by 4. 2. And you're taking away 2 of the x's, so how many are left? 1. 12 divided by 4. 3. And you're taking away 2 of the x's. Boom, there's your answer. That's it, done. The part people make mistakes on is the number 1. They forget. They're like, oh, it's gone. There's nothing sitting there. There has to be a 1. It has to be the same size as what you started with. So there has to be a trinomial there. There is a placeholder there. You had to have a number. All right, questions with that type of problem? Now, could it go further? Yeah. Maybe the thing in the parentheses could split up, and maybe it's a trinomial rule or a difference of squares or grouping. You might have to look at that later. Okay, that's called factoring completely, where after you do one type, you go to the next type and you check everything to make sure that it's went as far as it can. But that's common factors. All right. Do we need to do another common factor problem? Do we feel comfortable with that one? It's usually one of the easier ones. And you can take out negative signs as well if you needed to. So if all the numbers were negative, you can take out the negative sign with it. Just remember, when you're taking it out, you're basically dividing it. And you're subtracting the variables off. Okay, that was common factors. Let's go to trinomial rule. This is one that you guys, yesterday said that we spent way too much time in Algebra 2 on. It's true. And some people still don't understand it. I have one simple rule that I follow when I do my trinomials, no matter what they are. So I'll kind of do a couple examples. We'll do more tomorrow. But the basic trinomial rule. Let's start with an easy one, just to make sure we kind of understand it. Okay. All right. So x squared plus 8x plus 15. When you start, you have to make sure it's a trinomial. I know that's common sense, but if it's not a trinomial, don't attempt to do this rule. When you start, it is a trinomial. We check it doesn't have anything in common. You have to check that first. No common factors. Now what I would attempt to next is the basic trinomial rule, where you break up into 2 parentheses. Because trinomials are formed by 2 binomials actually multiplied together. That's how a trinomial is formed. So that's what we're going to try to check. Now, the rule that I follow every single time when I do this, typically I like to put it in descending order. Okay, you can go in ascending, it would still work. I usually like to put mine in descending order. I check the back symbol first. It's just the thing that I do. This is my rule that I always follow. The back symbol tells you basically what operations are going to be in the inside of the parentheses. Because these are going to be binomials. So there's going to be some operations in here, like a plus or a minus minus or a plus plus. There's something happening. The back symbol actually tells you what they are. If it's a plus sign, like this one is, when it's in descending order, if the plus sign's in the back, they're going to be the same operation. That's what the plus sign means. So if there's a minus sign in the back, they're automatically different. That's what that plus sign means. So what I mean by same operations, the symbols that are in here, like the plus minus signs, they have to be the exact same. Plus plus, minus minus. That's what the plus sign means. It tells you that right away. Now, to figure out what they are, all you have to do is look at this one. This is what they are. They are a plus sign. They're both plus plus. And it's not because of this. This one tells you they're the same or different. Same or different. This one tells you what they are. So it's plus plus. Yeah, we'll try another one again. But that's the rule I follow every single time. If you can get that rule done, you're almost there. It's the home stretch now, and now you're just trying to figure out numbers, because maybe it doesn't factor apart. But that's the hardest part that people always make mistakes on. They don't get the plus signs right or the minus signs. Next, what we do is we break up the first item and you break up the last item. That's basically what you do. You break up the first item and you put the first item broken up in the first spots in both parentheses. You break up the back item, you put those in the back spots. That's just where they go. So this is going to go here and here in the front. How do you break up x squared evenly? X and x. Easy peasy. Then we break up the back item. The back item goes in the back of each item. So that's going to go here and here. Now, this is where you have to do that little rule I did with like the 12 earlier, where you break up, the numbers and figure out all the different numbers that multiply to give you 15. We have 1 and 15, 3 and 5. That's pretty much about it. And to figure out what they are, you can put either number 1 and 15, or 3 and 5, or 5 and 3, 15 and 1, but they have to make the middle. And by making the middle, what I mean by that, whatever numbers you put here, the symbols out front are attached to it. So they're both pluses. So when you add them together, do they make this number? So obviously the option would be like 5 and 3. Those are both positive numbers, positive 5, positive 3, and they do make a positive 8. So that's how I think of it. I know that seems simple, but as you guys experienced in Algebra 2, it gets way more difficult, especially when they add more variables, they add more numbers to the list, and you're trying to figure out all the process for how it works. Okay, questions on what a trinomial looks like and how to attempt it. Now, obviously, I'm not going to stop there because there's too many options, because that's why they spend so much time in Algebra 2. Okay, that's the start. Let's try another one here. Trinomial again. Now, I just took a massive leap forward. Massive leap. Now we have more than just one letter. It is in descending order of x's. So x squared first, 5x, and then the y in the back. But it is a trinomial. Now, when you look at every single item, because it is a trinomial, there's 3 items there. Does every item have something in common? No. Because when you look at the front, this is a 1 and a 6, or 2 and a 3, there's x's. This one is a 1 and a 5, x and y, and that one's just a 1 with y and y. Not all of them have something in common, other than the number 1. One goes in there. But there's just nothing there. So we have to, since I can't take out a common factor to make this thing easier, we'll attempt to do the trinomial rule. So 2 parentheses is exactly the same way. We look at the back symbol first. This means that they're going to be the same operation. The plus sign in the back means they're going to be the same in the parentheses, so it's either going to be plus plus or minus minus. That's what the plus sign in the back does. And then I look at the one in the front. This is what they are. They're both pluses. It's just like the last one. Plus plus. Now this is where this problem differs, where you have to break up the first item and the back item, and those will both combine to make the middle, like the middle item, which is the 5. Okay? So, this is the part that people struggle with. They just don't understand the concept. Let's break up the back item first. How do you break up a y squared? Y and 1. Those go in the back, right? Because when you break up the back item, that goes in the back of both parentheses. That one's easy. Y and 1. Now, we have to break up the front item. So that's the 6. We have to break up the 6. Well, we have options. 1 and 6, 2 and 3. We're going to just attempt one. So we're going to break the x squared with this. We're going to go 2x and 3x. And when you FOIL it out, like first outer or last, you actually multiply it out, does it give you the 5 in the middle? And yes, it does. Because because now you're mixing the back numbers and the front numbers together to make the 5. So what I mean by that is like, what I think of to make the middle, I go outer and inner. That's how I think of it. So the outer multiplied together is 2xy. The inner multiplied together is 3xy. Does that make the middle term? Yeah, it does. Makes the 5xy. And again, how does that work? Like, if these were bigger numbers, how do you think of it? It's trial and error. It literally is trial and error, trying different combinations, putting numbers in different spots so that it actually works. Especially when they do something like this. There's a reason why I looked at gaps here. If they put another number in front, where they go like this, and they put a 12 here. Now you're like, oh man, now I gotta figure out how to actually like figure out those numbers that are involved to make that. So let's say the middle now is a 16. Now the middle's a 16. Will it even work? Can we even do it? Let's see. Well, actually, it wouldn't be 16. It'd be more like a. Let's see. 17. That's the number I'm looking for. Let's see. Yeah. All right. So 17. So, because I don't want to pick the last one, you could take out a common factor. All right, so on this one, now what we're trying to do is we're going to do the same rule. You're going to break this up into 2 parentheses again. You're going to have the plus, plus. All right, so now, it's all trial and error. We have to break up the back item, which is 12, y squared. 12 has lots of options. You saw them earlier. 1 and 12, 2 and 6, 3 and 4. Yikes, a lot. And then we have to break up the front item. So I'm going to just, what I would always do, my go-to rule when you're breaking out like big numbers, pick numbers that are really close together, right? So like if I'm breaking out 12, I'll go the 3 and 4 route first, every single time. If 3 and 4 doesn't work, then I'll try 2 and 6. And I'll eventually branch my way out until it's 1 and 12. So I'm going to go 3y and 4y. And then for the 6, I do the same thing, the 6x squared. I'll break that item up, and I always try to go the numbers that are in between. So I won't go 6 and 1 first, I always go 3 and 2. I always pick the middle numbers, the smaller numbers. So 2x and 3x. Alright, and then what you do is you FOIL, first, outer, inner, last. This is just what my go-to is, and if I need to switch any numbers around, I can do that. There could be more than one option, which is weird. That does happen on trinomials. Like, I picked, 2 and 3, 3 and 4, but maybe you found that 1 and 12 and 1 and 6 worked somehow. It could happen, not in this one, but it could happen. So just to prove that it does work, let's go with the outer and inner. So outer is 8xy. That's the outer. Inner is 3 times 3, which is 9xy, and that does make the 17 in the middle. So that was the option. But again, how do you know? It's purely trial and error. Like I don't have that set rule like, oh, this is how you do it and it works out every time. When it's weird numbers, front and back, you're literally just making combinations until it works. Until that middle number turns out to be a 17. And the number, what I'm looking for on all of these, this is what I'm looking for. I'm looking for that. I'm looking for what things are multiplying together to give me the item on top. This stuff that I'm writing down, this is just that idea I'm checking my answer a lot. Checking to see if the middle number works. Okay. Questions at all about trinomials? Okay, the only difference here is if they put a negative sign in the back, because everything I've done up till this point has a plus sign in the back. If they do a negative sign, that one, I consider those a lot easier. X squared plus 4x plus 12, or sorry, minus 12. So this is a trinomial rule. Still the same thing. You're going to break it up into 2 parentheses as normal. Now, the rule that I said earlier, you look at the back symbol first. So I do that. if it's a plus sign back there, the operations inside the parentheses are the same. Well, this is a minus sign, right? So they're automatically different. So, perfect. I don't even have to think about it. They're automatically different, plus minus. I don't even care which one goes where, minus plus. They have to be different. That's what the minus sign in the back tells you. Once you have that, then you can just do the rules like you normally would. You're going to break up the x in the front, so that's x and x. You're going to break up the 12 in the back, but now what you have to think about is whatever numbers you break the 12 into, because there was no numbers out front, whatever you break the 12 into, they're going to be subtracting basically, because this number will be positive, this number will be negative, and they have to give me 4. So, maybe like 6 and negative 2. That gives me 4 in the middle. This is positive 6, negative 2, that kind of thing. Okay, questions, comments about the concept of what we're doing, how you're supposed to think about those problems. Okay, I know it's not easy. Like, a lot of you have seen a lot of this stuff, so that problem is probably straightforward, but it just takes practice. Like, once you get going, you don't think about it anymore, you just kind of do it, and kind of go from there, break things up. Sorry, is that my phone? All right. We're good with the trinomials. I'm moving on. I'm not going to spend 2 weeks like algebra 2 with. Okay, we'll come back and we'll review that stuff later. All right, let's go to the difference of squares. This one I don't have to spend too much time on. Difference of squares. Okay, the big thing when you check this, when you're doing a difference of squares, like how do you know? How do you recognize the difference of squares? Like trinomial is straightforward. It has to be a trinomial. The common factors, you're just looking for things in common. But how do you know it on a difference of squares? Number one, it has to be a binomial. Your item has to be a binomial to start with. Number two, it has to be subtraction between them. There has to be subtracting items, right? Because it's literally called a difference. Difference is the key word for subtraction. Right? So you're subtracting items in the binomial. That's what I look for. But then the most common option here, like the common sense thing, is that your items in the parentheses, so the items that you're working with, the items that are in the binomial, have to be perfect squares. That's like the common sense. The perfect square chart is the perfect chart I gave you for when we did radicals and roots. So the perfect squares are these. 100, 121, 144, 169, 196, 225, blah, 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 blah. You guys get the idea, right? Perfect square numbers. So no matter what they are, they have to be that way. For your variables, for any of the variables, so these are the numbers, right? So when you're subtracting numbers, these have to be like the leading coefficients. If you have a variable, variables, other than the numbers, like these are the leading coefficients, the variables have to have even powers. They have to have even powers. 2, 4, 6, 8, 10. Keep going. So there's little rules that we have to check. Will it work? Some people just don't understand it. They don't think about that. Like these are the set things that have to happen. All right. Start this off here. Okay. So let's take a look at different squares. By far the easier of the two options, trinomial versus whatever, this is by far the easiest. 81x to the 4th minus 169. Like when you look at it, it's super clear. Like Those numbers are perfect squares, the variables are even, and there is subtraction in the middle of them. It is a binomial. Two items being subtracted. So it's following all the rules. Binomial subtraction, the items, all the leading numbers there in the front and the constant in the back are perfect squares. The powers are evens. It's kind of a no-brainer. If there was a plus sign in the middle, you can't do that problem anymore. It doesn't work. It's not a difference of squares. That would be a sum of squares. We're going to have a rule for that. But how are you supposed to do it? It's going to look like a trinomial. Right? It's going to be two parentheses. So you go plus minus. This is the rule that they teach you now for 2. Plus minus for difference of squares. And then all you do is you break up the items by using square roots. So like, for instance, what's the square root of 81? 9. Those are the numbers that you break up into. So it's 9x squared, 9x squared. That's the square root of x to the 4th, by the way. And then what's the square root of 169? Yeah, it's 13. It's the 13th number on my list. So it's 13 and 13. That's your answer. Like, that's the difference of squares. It's easy, you just break it up. You just have to know how to do square roots. But here's the thing I'm almost betting on. How many people actually know why that is the rule? Like, why you do that? Have you ever been taught that? Like, why do you break it up into 2 parentheses? Why is it plus minus?
Because when you would like FOIL it out, when you would normally see the 2 parentheses, it'll equal the same thing with the plus minus. It'll cancel out the...
Yep, I agree. So she's saying when you FOIL, the middle terms cancel. That's good. That is correct. That's number 1. Anyone else know a reason why? That is correct. You are correct, though. There's a second reason why. Because believe it or not, this is actually a trinomial. Yeah. You're saying more. You just said it was a binomial with a subtraction. It's actually a trinomial. They just didn't write it in descending order. In fact, what it is, it's this. 81x to the 4th plus 0x squared minus 169. They go in descending order. They just went by evens for powers. And it's actually a trinomial. They just put the middle term as 0, so because they're accounting for that middle term. And when you do the trinomial rule, the rule I just taught you a little bit ago, what do I look at first? The signs, right? I look at the back symbol, right? That's what I taught you earlier. We look at the back sign. What's the back sign?
Negative.
It's a negative. So negatives mean you have to go plus minus on a trinomial. You have to. And then, just like you said, you have to make sure the middle terms drop. So now you're going to FOIL and everything will cancel. So you just have to make sure the numbers you're putting in here are basically identical. So when you multiply like first, outer, inner, last, the inner and outer kind of terms, they're exactly the same digit. So the only way that I can make them the same is if I just take these numbers and break them up perfectly even. So 9 and 9, and then I break the other one to be 13 and 13. That way I'm multiplying when I go outer and inner, they're multiplying by the exact same digits. So you're right, you add opposite numbers together. But most people never see that. It's actually the trinomial rule, just written differently. Some people never get to see that. That's actually where it comes from. That's why it's always plus minus, because the minus sign in the back is a negative. Okay, questions? That was good. Okay, that's difference of squares. Probably the easiest rule of them all. All right, the last one I'm going to finish with today is the cube rule. This is my last one today. Cube rule. I'm not going to do grouping today. I'm going to say that for Friday. Let's do the cube rule. This will take us pretty much to the end of class here. All right, the cube rule. There's a couple stipulations for the cube rule for you to be able to take the cube factor. Okay. It's got to be a binomial. One more time. It's got to be a binomial. Number 2. This is the part where it can be different. The second rule, it could be a sum or difference. There's where we're gonna be, comparing the difference of squares rule versus cube. Cube, you can have plus or minus. It doesn't matter, it will still work for a cube rule. Now, obviously the leading numbers that you're working with when you're in your binomial, you have your parentheses. Your numbers have to be cube numbers. So all digits in that problem are cube numbers. Cubes. So the cube numbers that I have memorized off the top of my head. These are the cube numbers. All right, cube numbers are like 1 times 1 times 1, 2 times 2 times 2, 3, 3, 3, 4, 4, 4, 5, 6, 7, and I don't know anyone past that. Figure it out, but I don't have them memorized. These are the cubes. So those numbers in your parentheses better be these types of numbers. The power on the outside. Powers. And this is where some people have that, where they go too quick, because I told you the difference of squares has to be even numbers. The powers on these are not odds. It's not. It's multiples of 3. Powers on all variables. Powers on your variables are multiples of 3. So 3, 6, 9, 12. All right, does anyone foresee a problem with having multiples of 3?
You have numbers like 6 where it's a 2 and a 3.
Yeah. That's where, I'm not joking, when you're doing like a cube rule, and they're using powers of 6 or 12 or some even power, but it's multiple of 3, you could almost do the difference of squares to that problem in certain cases. You could actually choose. There's actually an option like, do I want to do a cube rule or do I want to do a difference of squares? And it doesn't matter, you'll get to the same answer in the end, which is crazy. So that's something we're going to look at probably on Friday. Tomorrow we'll look at like, what's that one type of problem that could go either way right when you start a problem? Do you do different squares or you do a cube rule to it right away? But let's do at least a cube problem. This will be my last problem today. Last one. We'll just do one of these, then we're done. Okay, so cube numbers has to be a binomial plus or minus. We'll go plus in this one today. Let's go with like 8x to the third. And let's pick one of the other numbers. Let's go 125. So you can kind of see it is a binomial. It's got multiples of 3. It's plus or minus in the middle of it. And the numbers are perfect cube numbers, as you can tell. But the rule for how you do a cube rule, it's going to be a small parenthesis and a large parenthesis. In Algebra 2, I think they call it like SOAP method. S-O-A-P, SOAP.
Same opposite always positive?
Yeah, that's the rule. Yeah, it's almost in every math textbook. That's why it's not like some weird unwritten rule. It's in every textbook. That's just the rule they teach. I think of mine like very, very different than like using SOAP. SOAP works. It explains the process. But this is how I think of it. The symbol here is just going to be whatever your problem is. So if your problem is a plus, you're just going to have a plus here. I know that's what SOAP means. It means same, opposite, always positive, right? Same. It's whatever, so whatever your problem is, I'm going to have a plus there. And the trick about doing this problem, you need to get the front parenthesis correct. If you can get the front parenthesis, that basically gives you everything you need in the back, because that's all I'm going to use. So how I get the front parenthesis, I'm going to take the cube root of these items. So what is the cube root, so the third root of 8? Well, it's 2, right? And what's the cube root of x to the third? X. Okay, so far so good. That's taking the cube root of an 8x cubed, right? So it's doing this. So that's what we did. That's the 2x. What's the cube root of 125? 5. So 5 times 5 times 5 gives you 125. Now that you have these numbers, now we can find the back parenthesis. That's really all I needed. I won't need the top thing anymore. So having these two numbers, the 2x and the 5, now I can find all the terms that go in here. That's all I use. So using the SOAP technique, you know, this is going to be the symbol that you had originally. The next one is always going to be whatever the opposite of it is. So if that's a plus, the next symbol will be a negative. And the last one, no matter what your problem is, the last symbol is plus. That's just how it works. So you should know the back symbol. You should never get that wrong. It has to be a plus in back. Now to find the items, this is the easiest thing I can teach you. Okay? Take the front item, the 2x, square both items. Square these, put a power 2 on both. What do you get?
4x.
That goes there. You just square the front. You do that for the back as well. Take the back item, take the 5, and put a power 2 on it. That goes back here. So you square the front number, square the back number. The middle item that's here, all you do is multiply these two numbers together. What's 2x times 5? 10x. That goes here. That's it. The middle term is made from just multiplying the two things in the front parentheses together. The 2x and the 5 make everything in the back. So if you have those two numbers, you're golden. You should know how to do it. You know, obviously, some people are really bad at this. Like, this is your first time seeing me do this for you. I'm not expecting you to walk in and go, oh, yes, I know how to do it. No. We'll practice this. We're going to try it more and more and more. Tomorrow, this is the one that people usually make mistakes on. We'll walk through the process of, like, going back and seeing, does it actually give me the correct answer? Because, like, we have to, like, FOIL it back together to see, does it give me the 8x to the third plus 125? So we'll kind of look at that. Okay. Today, that's it. I know that I took pretty much the whole class already. Tomorrow, we're going to look at the cube rule again. We're going to look at the difference of squares rule again, because I want to do that one problem where you can compare, or you can go either way. And then we're going to focus more or less tomorrow on grouping. Bring somebody, at least a couple people in here, bring textbooks tomorrow, because I'm going to ask for volunteers to, like, pick a problem out of the book, and those are the ones we're going to work on in class. Okay? So it's going to be kind of more hands-on tomorrow, where you need a calculator. Okay? All right. Homework due today. If you haven't turned in the baskets, make sure those get turned in if you haven't already.